Question 36. Many ionic compounds form their hydrate having formula MnO3x.YH2O or MClX.ZH2O. Which of the following hydrate does not exist? So students, we have been given 4 different hydrates. Let us start with the lithium first. So LiCl.2H2O. We know that lithium ion has a very high charge density, and as such its salt will often be hydrated in nature. So this will exist. Now if we look at the second and the fourth option, both of them are salts of magnesium, and we know that magnesium also has a relatively higher charge density as compared to the other group 2 elements. So students, these hydrates are also expected to exist. Now if we look at the first option now, which is barium. Now we know that if we compare the size of magnesium and barium, we know that the charge density of magnesium is going to be greater. So students, barium cannot have more extent of hydration as compared to magnesium because of the greater charge density of magnesium ions. So students, this salt should not exist, and we have to select option 1 as the correct answer to our question. Let us look at the next question now. Question 37. Consider the following experiment. So we have experiment 1, in which a mixture of water and AgCl is shaken until a saturated solution is obtained. Now the solution is filtered to 1 liter of clear filtrate, 10⁻³ moles of NaBr is added. In experiment 2, the examiner does a similar thing, only this time he has taken AgBr in place of AgCl, and in this case only 100 ml of the filtrate is taken out and 10⁻⁵ moles of NaCl are added. If you look at experiment 3 now, this time the salt is again different. Examiner starts with AgI and then does a similar thing as in the second experiment. So the filtrate is separated and 100 ml of the filtrate is allowed to react with 10⁻⁵ moles of NaCl. So the KSP values have been given to us, and we have to assume that there is no change in volume due to addition of NaCl, NaBr or NaI, and we have to select the correct statement. So the examiner is interested in knowing about the precipitate that will be formed in the experiment. So let us first try and figure out the condition of saturation for all of these salts. So we have AgCl. Its KSP given to us is 10⁻⁻10. So the solubility shall be equal to 10⁻⁵. If you look at AgBr, the KSP of AgBr given to us is equal to 10⁻⁻14. So the solubility shall be equal to 10⁻⁷. And if we look at AgI, the KSP value given to us is equal to 10⁻⁻18. So the solubility in this case shall be equal to 10⁻⁹ mole per liters. So let us look at experiment 1 now. So in the first experiment, we have AgCl. So the concentration of Ag plus ions shall be equal to 10⁻⁵. And if we talk about the Br minus which is added to us, so we have 1 liter of solution to which 10⁻⁻³ mole of Br minus is added. So we can have the concentration of bromide ions that will be equal to 10⁻⁻³ itself. And if we look at the ionic product, we can call it IP. The IP is equal to 10⁻⁸. So students, we can clearly see that this is greater than the solubility product, which is equal to 10⁻⁴. So students, in the first experiment, AgBr will be precipitated. Let us look at the second option now. In the second option, we have a saturated solution of AgBr. So the concentration of Ag plus ions shall be equal to 10⁻⁷ units, as we had seen before. Now the examiner has taken 100 ml of the filtrate and has added 10⁻⁵ moles of NaCl. So again we can find out the concentration of the chloride ions, that shall be equal to 10⁻⁴. So if we talk about the ionic product now, the ionic product shall be equal to 10⁻�11. And students, we know that the ionic product in this case is lesser than the solubility product, that is equal to 10⁻⁻10. So students, in the second experiment, there will be no precipitate. Let us look at the third experiment now. In the third experiment, we had a saturated solution of AgI. So we can find out the concentration of Ag plus ions. That shall be equal to 10⁻⁹. Now if we try and figure out the concentration of the chloride ions added, so it is the same data as given to us in the previous question, and we have seen that the concentration of the chloride ions shall be equal to 10⁻⁴. So students, if we talk about the ionic product, that ionic product comes out to be equal to 10⁻⁻13. and that is definitely lesser than the solubility product of AgCl, that is equal to 10 raised to the power minus 10. Students, there will be no precipitation in the third experiment as well. So if you look at the options, the first statement is incorrect. The second statement is also incorrect. The third statement is correct, students. In experiment 1, AgBr will be precipitated. So the fourth statement automatically becomes incorrect. Students, in this question, we have to select the correct statement. So we have to select the third option as the correct answer to our question. Let us look at question number 38 now. Consider the following sequence of reaction. So the examiner is interested in the products. So let's try and figure out the products of this reaction. So we have BCl3 reacting with NH4Cl. Students, this is going to produce B3, H3, N3, Cl3. You can also look at the structure of these species. So we have B, N alternately connected to form a 6-membered ring. And the chlorine atoms will be attached to the boron, whereas nitrogen will be attached to the hydrogens. So this is our compound A. Students, this compound will be aromatic. So there will be coordinate bonds between nitrogen and boron. Now, when this A is allowed to react with NaBH4, we're going to have all the Cl replaced by hydrogen ions. So we have B3N3H6, which is also known as borazine or inorganic benzene. And now if you look at the reaction of borazine or inorganic benzene with HCl, we're going to have hydrochlorination of the BN double bond, and we are going to get this structure. The hydrogen will attack the nitrogen atom, whereas the chlorine will attack the boron atom. Students, the species present here are going to have a charge. All the borons will be negatively charged, whereas all the nitrogen atoms are going to be positively charged. So let us look at the options now. Compound A is B3N3H3Cl3. Students, this statement is correct. Compound Y is B3N3H6. Students, this statement is also correct. This was our compound B, which was inorganic benzene. If you look at statement 3 now, when 3 moles of HCl react with 1 mole of Y, so Y was borazine, and upon reaction with 3 moles of HCl, we had seen that it forms B3N3H9Cl3. So this statement is also correct. So students, automatically the fourth statement should be incorrect. Let us just check it for the sake of it. When HCl react with compound B, H plus attack on boron, whereas Cl minus attack on nitrogen. Students, this statement is incorrect. The H plus attacks on the nitrogen, whereas the Cl minus attacks on the boron. So out of the given statement, statement 4 is incorrect, and the examiner is also interested in talking about the incorrect statement. So students, we have to select option 4 as the correct answer to our question. Let us look at the next question now. Question number 39. AlCl3 is electron deficient compound and exists as Al2Cl6. Select the correct statement about the structure of Al2Cl6. So if you look at the dimer of AlCl3, so the aluminium atoms are sp3 hybridized, and there is chlorine bridging in the molecule. So looking at the options, it has 3 center 2 electron bond and 2 center 2 electron bonds. Students, it has 2 center 2 electron bonds, which are the terminal AlCl bonds, but it does not have any 3 center 2 electron bonds. If you look at the second statement now, Al2Cl6 is a planar molecule. This statement is incorrect. Both the aluminium atoms are sp3 hybridized and the molecule is non-planar. This is also incorrect. Let us look at statement 3 now. It does not give ions when dissolved in water. Students, this statement is also incorrect. Al3 plus is extensively hydrated and it forms AlH2O whole 6 3 positive. So it also gives chloride ions on dissolution with water along with this ion. So this statement is also incorrect. It does give. If you look at the fourth statement now, it contains 3 center 4 electron bonds and 2 center 2 electron bonds. Students, we had already seen that the 2 center 2 electron bonds are present. And if you look at the bridged AlCl-Al bonds, so these two bridge bonds are 3 center 4 electron bonds, in which these 4 electrons all belong to the chlorine atom. So students, we have to select the correct statement for this question, and we have to mark option 4 as the correct answer to question number 39. Let us look at question number 40 now. Which of the following statement is incorrect regarding fullerene? So looking at the first option, fullerenes can have carbon atoms up to 350 or above. This statement is correct. Fullerenes are produced by heating of graphite in electric arc in presence of inert gas. Students, this statement is also correct. These are all lines from NCERT. It is a fact-based question. Buckminster fullerene is aromatic in nature. This is also correct, students. If you look at the fourth option now, C60 is more stable than diamond but less stable than graphite. Students, this statement is incorrect. If we talk about the delta HF values of carbon, graphite and fullerene, we have the delta HF of graphite as the least, followed by diamond, followed by fullerene, C60. So it is less stable than both diamond and graphite if we talk about the thermodynamic stabilities. So students, we have to select option 4 as the correct answer to our question. Let us look at the next question now.